In this lesson, we are going to talk about filters. Okay, we had earlier seen that my rectifiers are producing pulsating DC. Okay, if you're looking at a half wave rectifier, then this is your output waveform, or if you're looking at full wave rectifier, this is your output waveform. In both the cases, your value of voltage at the output is pulsating, it is not constant. Okay, ideally what we want is a constant DC to be given to our devices. Therefore, with our rectifier, what we are going to do is we are going to interface a filter so that my output can be smoothened. Okay, so I want a smooth output which would be given by my filter. Okay, so filter basically is something that's going to reduce my ripple content or reduce the AC components in your output. Okay, so just see, your filters basically are made up of either L, that is your inductors, or C, that is your capacitors, or combination of these two. Okay, now just recollect what is the impedance offered by an inductor. Okay, impedance offered by an inductor is omega L, which is 2 pi into frequency of your voltage into L. Okay, your impedance offered by a capacitor is 1 upon omega C, which is equal to 1 upon 2 pi into frequency of voltage into C. Okay, so if you look at a DC voltage, okay, if you look at a constant DC voltage, then its frequency is 0. Okay, if your frequency is 0, then this thing, the impedance offered, basically becomes 0. Therefore, for a DC voltage, your inductor acts as a short circuit. Okay, and if you look at this guy over here, if your F becomes 0, that is, if you're looking at a pure constant DC voltage, then what you have over here is 1 upon 0, which basically means infinite impedance or resistance. Okay, which basically means a open circuit. Okay, not a short circuit but a open circuit. So for a DC, your inductor acts like a short circuit and your capacitor acts like a open circuit. Okay, so think of it in this way. Let's just say you have your rectifier over here. Okay, that's your rectifier. Okay, and you're connecting your load like this, that's your RL. Okay, now if over here I just apply, let's say, a inductor. Okay, I'll use a different color. I have an inductor over here. Then what's gonna happen is, over here you have your rectified output. Okay, that's containing AC as well as DC. Okay, as we have seen, my inductor offers no resistance to a DC voltage. Okay, it basically acts like a short. Okay, so your presence of inductor would allow your DC components to pass through, but your AC components would be blocked or resisted. Okay, so the components that are received across your load resistor would be predominantly DC. Okay, so basically what you're going to get at your load resistor is a voltage which is less pulsating than what you have given as input. Okay, so this voltage would be more pulsating in nature as compared to the voltage available across over here. Okay, so in general, your inductor is always connected in series with your load. Okay, so this is your RL and this is your inductor. Now if you look at a capacitor, let's just say this is your rectifier. Okay, and you have your load resistor like this. Now if I apply a capacitor like this, okay, then we have seen that my capacitor basically acts like a open